Hello and welcome to Maths Plus. Thank you for joining. Today we will be doing integration. So let's look at the formula for integration in your log tables. So we go to the formula which is on page 26. So if we integrate a function with a power, we can increase the power by 1, and the new power will also go below as a denominator. Okay, so the important thing here is to do it in 2 steps and also not to get mixed up with differentiation. So let's look at a simple function here, just to try to understand what we're doing or integrating. So I'm going to create a constant over here, and the f of x will be equal to a constant of 2. The variable down here in the x-axis, okay, will start at 0 and we will go out to a certain x value. Just call it x1. So when we integrate the function between 0 and x1, we will get the area under the graph. So we could say that the area of f of x within the integral and the limits of x1 and 0 dx could be equal to, so the function there is 2. So let's integrate the function. So 2 will go to 2x, and let's apply the limits. So between x1 and 0, okay, so the area there will be 2 by x1. So that makes sense, doesn't it? Because the height there is 2 and the width there is x1. Okay, so that's the basic principle behind it. So practice the integrals, become a real expert at doing them, so there's no hesitation. If you have an integral where you do not have the limits, well, we can call that an indefinite integral. Okay, which will give you a function of area, but it will be a variable, so we could call it the integral of f of x dx plus c. So this value accounts for the fact that it's variable and the limits have not been applied yet. So write the plus c always when you do not have the limits. Okay, so let's look at different combinations now and let's practice them. So the first one I want to do is the integral of just a straightforward function, x squared plus 7 dx. Okay, so let's apply the rule now, and we're going to go with the x squared will become x cubed over 3, so plus 1 at the power, and the denominator goes below, and the 7 is a constant, so 7 by x will give you the area, so 7x. And you can see here we do not have limits. Okay, we do not have limits here or here, so therefore put in the c value then, plus c, and it's an indefinite integral, and that's all you need. Okay, let's do another one. Okay, this one looks more challenging because of the power is underneath the line and it's reciprocal. So let's apply the integral to that. So first of all, we're going to rearrange the function so we can see the true power, which is negative 3 dx. So now let's apply the rule. Just be careful here. So we're going to write in the power here, just to be sure. Minus 3 plus 1, which is x to the n plus 1. Okay, and the next step will be to repeat that number below, which is the n plus 1. Okay, so let's see the result. We put in our plus c, don't forget about that. So we got x to the minus 2 over minus 2, which is equal to then 1 over 2 x to the 2 negative plus c. Okay, so take your time with that one and make sure that the powers make sense. Alright, so this one looks more challenging because we have a power outside the bracket and also we have a function inside. So we have two functions occurring here in the original function. Alright, so the chain rule, which is in differentiation, doesn't really apply here. So what we have to do in integration, we have to express out the function into all the terms within. So therefore we need to multiply out the brackets first and then apply the integration across the board. So let's do that. Okay, so just make a note here, just a mental note, okay, for yourself, that the chain rule doesn't apply. Okay, there's no chain rule. Okay, here. Okay, so we have to multiply it out or factorize and see what we get. Okay, so let's look at it. So let's square everything. We can do this quickly. So x squared plus twice the cross multipliers. Remember, x over x is the result of x multiplied by 1 over x. So we're going to get 2 of those. So it'll be 2 by 1. And then finally then we will have 1 over x squared, which is 1 over x by 1 over x. So we just write it as 1 over x squared. Okay, just take your time doing that. Okay, so now we apply the rule. Apply integration, okay, after, expressing it out. This is very important to remember. Okay, so this is pretty straightforward now. So the 2 becomes a 3, double up below. The 2x is the result of integrating 2. Okay, and the x to the power of minus 2 is the same as 1 over x squared. Okay, plus 1 above and below, and we will get x to the minus 1 over minus 1, which is also equal to, let's do that. So it's going to be minus 1 over x. Okay, and what do we need at the end? Well, we just check for the limits. Okay, they're not there. Okay, so put in your plus c because it's indefinite integral again. So maybe try that yourself because it's a very good one to practice. It's challenging and also it's technically sound because it covers nearly every combination. Okay, so let's go on to the integration of trigonometric functions. So again, this looks like the chain rule in differentiation, but let's apply the integral with respect to x. So look up page 26 and you'll see the table of conversions. So the sign will go to cos, and you check the sign then. You check the is it positive or negative. So it will actually be negative. So negative cos of 3x. It also has an internal function of 3x. So we will place the 3 below. Okay, so it doesn't go as a multiplier, it goes as a divider in integration. Put in your plus c and it's complete. Alright, so you probably know how to do the costs after looking at the first one. So let's apply the integral. Cos of 7x dx. Okay, look up page 26 of your logs again, and we can see it'll be sine, positive sine of 7x. Okay, and the 7 goes below. Okay, just remember that, goes below for integration, and the plus c again. And that's all done. Okay, and finally, let's look at the exponential function for integration. So again, page 26 will give a format which is similar, and we can see e to the ax will go to 1 over a. See, the number is always going down, by e to the ax. So let's apply this over with our specific combination. So the integral of 4 e to the 2x dx is equal to 4 multiplied by 1 over 2 e to the ax, which is the 2x, plus c, and just simplify by dividing by 2, and we get 2 e to the 2x plus c. Okay, so that's a range of different integral type functions. We have trigonometric, exponential, and we have algebraic. So now let's do some exam questions and let's apply the integration. So these are past leavingcert higher level questions, and we need to pay attention, okay, to what's going on, because they're all different and you'd have to make your correct decisions at the start. So first of all here, use the function h of x to find the average height. So the average height is very, very specific. So h average, okay, so we'll apply the average value theorem. So 1 over the width of the interval, b minus a, multiplied by the area, which is f of x dx, will give you the average height. So I'm just going to make a description here. 1 over the width, this will help you remember, multiplied by the area. Okay, it makes sense. So if we have a trapezoid like this, and we have A and B, but we have a constant width, h, the width, okay, divided into the area. Okay, so if we write it like this, A plus B okay, over 2 multiplied by h is equal to the area. So if we divide, okay, by h, because a plus b over 2 is the average height, so we get a over. Okay, so the area over the width is the average height, and that's the trapezoid there. Alright, so you don't need to do that in the question. All you have to do is just apply this function, 1 over b minus a. So it's b and a, upper and lower. Okay, so let's put all this together, but we do need to understand the format of the formula before commencing. This is the most important aspect, because once you make that decision, it's pretty straightforward from that point onwards. Okay, so let's apply it. So we're going to get the integral. So the integral of h of x dx. Okay, and we're going to divide that by b minus a. Okay, and that will give us our average height. So we could write it like this. 1 over 75 minus 0 between 75 upper and lower h of x dx. Okay, let's put in all our values now and integrate. So we have 1 over 75. So let's look at 0.01 x cubed. So we get 0.01 x to the 4 over 4. And let's keep going. You can follow this pretty quickly. 0.12 x squared will go to x cubed over 3. And we have plus 3.6. The x will go to x squared all over 2. And 5 will go to 5x. Okay, and we write the limits here, 75 and 0. All we need to do here is put in the 75 because 0 will not give an output. So do your calculations. And we get 1 over 75. That's our width. 1 over the width multiplied by the total area, which will give 1535.156. We want 2 decimal places. So just write out the answer here first of all and write 68, which is equal to 20.47. Okay, to 2 decimals. Okay, so that's the average value theorem applied, okay, across the interval. I hope that makes sense. It's very important. It's usually part C of an exam question. Alright, so let's go on to another one. First of all, we need to integrate the function. So it's a very straightforward question. So the 4x cubed will go to x to the 4 over 4 multiplied by 4. So that will give a result of x to the 4. Secondly, the 6x will go to minus 6 over 2, which is minus 3 x squared. And then the 10 will go to 10x. And as you know, you put in your plus c as it's indefinite. Okay, so that's part A. Very straightforward. You will lose marks if you do not put in plus c. So be careful about that. So part B, we have a plot. But they're saying that this plot, okay, has a f dash or a differential of 6x squared minus 5x plus 109. So we have to prove that f of x is this original function. So what we need to do here is apply the Anti-Derivative Theorem. So let's write out a general statement for the Anti-Derivative Theorem. So the integral of f dash x dx is equal to the original function plus c. So it's the reverse process. So they call it the antiderivative. Okay, so we had the average value theorem in the last question. Now we have the antiderivative. So whenever you see the f dash x, it's usually going to be the antiderivative theorem. So let's apply integration to the f dash x. So the integral of 6x squared minus 54x plus 109 dx is equal to 2x cubed, that matches this, perfect, minus 27x squared, that makes sense, and then 109x, okay, and also we have to put in our plus c. Alright, so we can solve for c now and see can we get to minus 106. So let's do that. So because of this point here, let's look at this point. A is 2, 0. So that means when I substitute in 2 into f of x, I will get a result of 0. Okay, so let's do that. So f of 2, okay, is equal to, so substitute 2 in everywhere. So we get 2 by 2 cubed minus 27 by 2 squared plus 109 by 2 is equal to 0. And also we have a plus c in there as well. So we have a plus c. Alright, so multiply everything out and we're going to get c is equal to minus 126. Okay, and that means that, you know, that the f of x is equal to, so the f of x is true. Okay, so that was the anti-derivative theorem. Anti-derivative. So we work back. Sometimes you could have speed and you need to get the distance formula. So you apply the antiderivative to the speed or the rate of change and you can go back to the distance formula. Okay, so let's look at another one. So we're finding an area of an exponential function. These are very popular questions. I've already sketched the functions out to speed up the process. So all we need to do is apply an integral to get the area enclosed. So just let's look at it a bit carefully. We have an exponential function going upwards, e to the positive x, and then an exponential function going downwards, e to the minus e to the x. Okay, so they're inverses of each other. Put the minus in there. Okay, so what we need to do now is to set up the integral. So I'm just going to write a general one. So I'm going to go the integral, okay, is going to be the upper function, the upper minus the lower between the limits. So we can see the limits there are 0.75 is on the right, so we call that B, and then at A is the lower. So upper minus lower for everything. So let's put all this together. So sometimes you have to find the point of intersection in the functions. In this question, they give us a limit line, which is very good. It helps to speed up the process. Okay, so the integral of e to the x is the upper function over 0.75 to 0 dx minus the integral of e to the minus x, the lower function, dx, again the same limits. So that's going to be the area enclosed. Also, it's worth noting that the integral is the area between the graph and the x-axis. Okay, so let's put all this together. So we can simplify by putting the combination together into one overall. So e to x minus e to the minus x dx. Okay, and let's apply integration to those. So look up your logs again. So logs page 26. And remember, when we're integrating e to the ax, okay, we'll get, because the minus 1 is like an a, so we get 1 over a e to the ax. So this minus 1 may become hazardous, so we would place it below, and therefore it would change the sign. So that's the tricky part of this, so just pay attention to that. Okay, so the answer here will be e to the x, the integral of e to the x, and the minus now will become a plus, because e to the minus x integrated went to minus 1 underneath the line, e to the minus x. So I change the sign, and when I change the sign I will have two negatives here, and now it's a plus. Okay, and we put this between 0.75 and 0. Put everything into your calculator and we will get a result of 0.5894 units squared. Okay, and that's our area enclosed. So the most important aspect about this is the setup, where you do the upper function minus the lower function, and the upper limit, the right hand side, minus the lower limit on the left hand side. So be able to set that up and then integrate effectively, and it should all come together. So I recommend practicing those to get really good at them, because they're straightforward. Alright, so finally we're going to do a trigonometric function, and I have the first part worked out. So I just want to introduce the graph. So it's a trigonometric function, and in part A we needed to substitute in 76 into the function to get the daylight hours for that specific day of the year, 76 days after March 21st. So that on that particular day, when I substituted in, I set my calculator to radians, because I have 2 pi inside the period. So substitute in your 76 and we'll get an output of 16.84 hours. Multiply the 0.84 by 60 and we can get it in hours and minutes. Alright, so let's look at the next part, which involves integration, now that we know what the function is about. Alright, so the function is there now. So on March 31st, we have the starting point, of the cycle. And as you can see there, we want to get the average height, or the average length, for the first 184 days of that cycle. So if we start at March 21st, we can go 184 days, and the average height would be up here somewhere, and you can see it would be positive. Alright, so as you know, we have to apply the average value theorem. So let's apply this. Over here we have a difficult function to integrate, because we have sine and also we have like an internal part here. So let's see what we can do to make that as straightforward as possible. Right, so the integral, so the average, the h average is going to be 1 over 184 minus 0 by the integral between 184 and 0 of f of t dt. So that's going to be 1 over 184 by the integral inside. So the 12.25, we know we've that covered already, so that will go to 12.25 t. And let's look at the sine function. The sine will actually go to cosine, So I'll check page 26 again, and we'll put a negative here. Alright, so then we're going to divide. We change the cosine. Now we got to deal with the 2 pi over 365. So we're going to divide that under the function. So we could just place it there. 4.75 can go there. And let's divide it in. So I would just place it under here with the calculator. Okay, can work it out later when doing calculations. So place it underneath. It's all about the placement. And then inside you will retain the period. So 365 under 2 pi by t, the input. And that's going to be between 184 and 0. So all we need to do now is compute everything out. So I want you to look very carefully at this, because the sine went to cosine, and then the 265 under the 2 pi will go under the function. It will divide in. The 275 stays outside. It's a constant. Okay, so that's pretty tricky. So once you get past that hurdle, all you have to do is set your calculator to radians, and let's work out the value inside. So we have a value of 2805.78 or 777. Okay, so we want to get the nearest hours a minute, so let's just compute it all out. So it'll be 15.248 hours. We want minutes now, so the 0.248, multiply that by 60. So that's very, very close to a quarter of an hour or 15 minutes. So the average height for the first 184 days, H average, is equal to 15 hours and 15 minutes. Okay, so here is just a recap. So when you're doing the integration, if we have two functions, it's going to be the upper function minus the lower function is the area enclosed. So I hope you enjoyed the integration, and there will be many more videos like this in the channel. So study the video, try some questions, and thank you for joining Maths Plus. Like and subscribe to the channel.